Hi everybody, today we are going to be talking about the radioactive or nuclear decay. So first we have the nuclear belt of stability, and I'm going to discuss a little bit about this, and don't worry if it doesn't make sense right now because we'll go into more detail as we go through the video. So as you can see on the x-axis here we have the number of protons, and on the y-axis we have the number of neutrons. The whole purpose of the belt of stability is to predict the type of radioactivity, and it will also show us that an isotope is more stable if it has a ratio of protons neutrons that is 1 to 1. So if we have nuclei above the belt of stability, so somewhere over in this region, it's going to have a high neutron to proton ratio, and it will usually emit beta particles, which means it will give one less neutron and one more proton. And if we have nuclei below the belt of stability over here, we'll have low neutron to proton ratios, and they will emit positrons or capture electrons, which will give the isotope one more neutron and one less proton. And if we have nuclei with an atomic number greater than 83, meaning anything this way, the isotope tends to undergo alpha decay, which means it loses 2 protons and 2 neutrons, and it will get smaller way faster. So what are the types of radioactive decay? As I mentioned before, we have alpha decay, beta decay, positron emission, and electron capture. But the one thing we did not talk about was gamma decay. So first of all, how do we know if a nucleus is radioactive? There are 4 different steps that we want to ask ourselves. First, say we have the isotope 7,3 lithium. So this means we have 3 protons and 4 neutrons, which would give our nucleus an odd even ratio. So we would want to come over here and look at our odd even nucleus. And for an odd even nucleus, if the mass number of the isotope differs more than 1 atomic mass unit from the rounded atomic mass on the periodic table of elements, then the nuclide is radioactive. For an even nucleus, if the mass number of the isotope differs by more than 3 atomic mass units from the rounded atomic mass given on the periodic table, then the nuclide is going to be radioactive. For an odd nuclei, only 5 isotopes are non-radioactive, which are listed here. All other odd nuclei are going to be radioactive, and all isotopes with more than 83 protons are going to be radioactive. So how do we predict the type of radioactive decay? In other words, once we go through the process from the last slide, how are we going to know if it undergoes alpha emission or beta emission? So first, if we know that our isotope is radioactive, we're going to say if the mass number of the radioactive isotope is more than the mass number on the periodic table, then the isotope will decay by beta emission. So for example, if we have carbon 14, we're going to go on over to the periodic table and see that the average atomic mass listed there, the mass number on the periodic table, is 12.01. Now 14 is greater than 12.01, so we're going to know that this will decay by beta emission. Next, if the mass number of a radioactive isotope is less than the mass number on the periodic table, the isotope will either positron emit or electron capture. So if we have lithium 6, we'll go over and find lithium on the periodic table, and the mass number there is 6.94. Obviously 6 is less than 6.94, so we know that it will decay with either positron emission or electron capture. And lastly, isotopes with protons greater than 83 will alpha emit. So examples of that would be radon or francium. And next, we need to know our nuclear symbols, which are going to be critical when balancing a nuclear equation. And we will run through some examples in our next slide. Our first example here is going to deal with beta decay. So say we have the example as shown. And we need to find out what number symbol we can insert over here to balance out the equation. So we know that we have 234 as our mass number here and 234 as our mass number here. So 234 plus what equals 234? That would be 0. So we know that our mass number over here has to be 0. Now we have 91 here and 90 here. So 91 plus what is going to give us 90? That would be -1. And if you refer to the last slide where we talked about nuclear symbols, 0 and -1 go with an E, which is going to tell us this is beta decay. We just need to make sure these numbers up here balance and these numbers down here balance as well. Next, we have an example with alpha decay. So our example is as follows. Right away, we can tell this is alpha decay because we see the 4,2-He. So we know that's the nuclear symbol for alpha decay. So we need to say what plus 4 equals 210. Now we know that would be 206, so that's going to be our higher number. Then we also have what plus 2 equals 84, which is 82. Go to the periodic table. What element is 82? That would be lead. So we're going to write the symbol for lead, and that is going to balance the alpha decay equation.